Hi everybody, this video is how to do scientific notation, which is a different way of writing numbers. To start things off, you should have a copy of these guided notes, which are up on the front counter. The normal way that you've seen numbers represented is regular notation. So for example, if we're looking to write the number 208 million, we would write 208. And then to represent that it's millions, we have to add a bunch of zeros and commas. If we want a different way of writing that without writing all those zeros, we'd look to scientific notation. This is a shorthanded way of writing numbers that are big, like the one we just did, or small. In scientific notation, the number is written as the product of two different factors. So for example, if we write this in scientific notation, excuse me, we've got our first factor at the beginning here. And this always starts us off with a number that is here, that's between 1 to 10, and then there may or may not be a decimal here, and then there's our other digits over here. Our second factor is always going to be a power of 10. So our second factor over here is telling us how big it is. So like when I say millions, that's just telling us how big the number is. When we're changing from regular notation to scientific notation, like we're going to do in these first couple problems, if we're moving the decimal to the left, the exponent will be, well, if we look at this first example here, the decimal starts here and it ends up moving to here, so that's to the left. Our exponent up here is positive. So in this blank, go ahead and write the word positive. This means that if we've moved the decimal over to the right, then our exponent is going to be negative. Take a moment to pause the video and review the first two examples that explain in words how those problems were done. Okay, and let's go and do this third problem together. So our number has the digits 8, 9, and 7. The exponent up here, -3, says we're going to be moving the decimal 3 places. Since it's negative, that means that we originally needed to move the decimal to the right in order to put it where it was. So it must have started over here. If you're currently thinking, wait, what do I put into those two blanks then? As a reminder, our placeholder is going to be zeros. So we got 0 and 0. So our original number would have been 0.00 and then the 897. You'll also notice as a general trend with scientific notation, if the original number is big, like in the first two examples, 420,000, that's a big number. Or 735 million, also a big number. If we look at those exponents, these two exponents are positive which tells us that that number is going to be big. But meanwhile, this one here, which was negative, means that the number is going to be small. And for those of you who like a little bit more info, if it's going to be a positive exponent, then the original number is going to be bigger than 1. And if it's negative, it's going to be less than 1. So if we look at that exponent, it's just going to tell us how big or small that number is. All right, let's do one more example problem. So if we look at this last number here, we need to first decide where we're going to place the decimal. The decimal should come after the first number that you say that isn't 0. So if I go to say this number, just saying the digits in order, I would say 0.00000014. The first thing I said that wasn't 0 was 1. The decimal should go right after that. Let's count over how many times we have to move the decimal to get there. Gotta go 1, 2, 3, 4, 5, 6 moves. So over here, on this side, we're going to rewrite this now as 1.4 because those were the numbers that weren't zeros. We're going to multiply that by 10, and we had to move the decimal 6 times. So our exponent is 6. The last thing that we're going to add, because we moved the decimal to the right, and because this number is small, we're going to add a negative. All right, what if we want to do the opposite? What if we want to go from scientific notation to regular notation? Well, scientific notation tells us the number, the digits themselves, and how many times we're going to move the decimal. So since on this first example, it's 5, we're going to move the decimal 5 times, and then place zeros into those empty spots. Take a moment and review the first 2 examples that are already written on how to do them. Okay, let's go and look at the third example here. Our number is 0.0042. Our decimal should go between these digits because the first thing I said was 4, so it should go 4 decimal number. Next, we need to count how many times we're going to be moving the decimal. So we move it 1, 2, 3 times. We should also note here that this number is less than 1. All right. Over here, when we go to write it, this would be 4.2 times 10. And we had to move the decimal 3 places. The original number was small, so we're going to put in a little negative sign there. That's how we'd write that in scientific notation. All right, for our last example, we have 7.51 times 10 to the negative 5. This exponent, the negative 5, tells us that this number was small. So when we decide to move the decimal, we should move it the direction that's going to make this a smaller number. That's going to be to the left. So we go 1, 2, 3, 4, 5 times. Decimal should be here. We got to put in a whole bunch of zeros here. So looking at what this number should look like now, we should have decimal 0.0000751. And so that's the answer we're going to write over here. We've got decimal 0.0000751. Okay, on this page here are some practice problems. I want you to try changing things from regular notation to scientific notation, and then from scientific notation to regular notation. Make sure you check in with your neighbors, and if you're not quite sure on a problem, you may want to look at some outside resources to double check. Last thing I want to mention is the most often missed problem here. It's number 9. Number 9 is a little bit tricky. As a helpful hint, you're only moving the decimal right there because the first digit there is 1. So it should be 1.89 and a little bit more. Hopefully this video helped. If you want to see any of these notations worked out in person, please go ahead and feel free to ask me sometime soon. Thanks.